Well, the name is essentially like a registration plate on a car. It's a unique identifier. So the 2024 bit just tells you it was discovered in 2024. The letter Y tells you it was discovered in the final fortnight of 2024, and the rest of it tells you which object in line it was when it was found. So that's all fairly simple. It's an object that goes around the sun about every 4 years, so it'll come quite close to us in 2028 and really close in 2032. And we don't know exactly how close yet because we need to get more data to get a better handle on the orbit, the path it's following around the sun. But we're working on that.
So if it does emerge more of a threat as we get closer to 2032, what actions can relevant space agencies even take?
Well, we live at a really interesting time. We've had life on Earth for 3 billion years, and it's only in the last decade or so that any species on Earth has been able to recognize a problem, identify the objects, and predict they're going to hit us. And in the last couple of years, NASA demonstrated the ability to deflect asteroids with their double asteroid redirection test. So if the worst came to the worst, in 2028, we figure out that it's definitely going to hit us. That's when it has its next flyby. That gives us 4 years. In those 4 years, we can prepare potentially to deflect it. More realistically, though, I think it's a case of figuring out if it's going to hit us, where it will hit. Because this thing's only going to cause damage on an area of about a city-wide scale. It's not the kind of thing that will cause continental devastation. And if it's going to hit somewhere safe, you don't need to do anything.
And safe meaning oceans, and what might be the impact in that scenario?
Potentially. So it depends exactly what this object's made of, and this is one of the things we're interested in. The most likely scenario is it's a rubbly type object, like a congregation of rock and rubble held together fairly loosely. And in that case, it'll detonate in the atmosphere somewhere between 10 and 30 kilometers up and give off a shockwave that booms down towards the Earth, and that'll be what causes the damage. That happened in 1908 in Siberia in a place called Tunguska, and it leveled an area of trees comparable to Greater Sydney. So that's the kind of area you're looking at. But if that was happening over wilderness or over the oceans, it's probably not really a threat. You just make sure nobody's around, you evacuate the area.
Yes, and of course, and there's a lot of attention now on YR4 for the next few years. What might scientists such as yourself learn from such an asteroid?
It's a really interesting object. It's moving on this quite elongated path, so we want to know what it is and where it came from. Normally with these kind of near-Earth asteroids, they come from the asteroid belt originally, but this has an orbit that's so eccentric that I wouldn't rule out it possibly being a comet instead, a dormant comet, one that's pretty much asleep essentially. So that'd be the kind of things I'd be looking to learn about it. But more critically, we really want to know what it's made of and whether it really is going to hit us. At the minute, the latest numbers from NASA are 1 in 67. That's the likelihood. But in 2028, it will either be a definite hit or a definite miss. And then 2032 will come along and we get to watch the show.
Yeah, and if it is a dormant comet, like you say, it could possibly be, what makes a dormant comet reactivate, I suppose?
Well, you can get comets reactivated if something cracks the surface, if something hit it, for example. So NASA attempt to deflect it, they make a crater, they expose icy material that has been buried. That could cause the comet to turn back on, start activity, which will push the comet around a bit and make it a little bit less predictable in its behaviour. Now, I should stress, I think the most likely outcome is that it's a rocky object, like Bennu, the asteroid that we visited with the OSIRIS-REx mission recently, rather than a comet, but I wouldn't rule it out.
Yeah. And on another matter, the Federal Aviation Administration in the US is demanding SpaceX investigate after parts of a spacecraft fell onto islands in the North Atlantic Ocean. Does this sort of open up discussions about how much responsibilities space agencies need to take when it comes to their space junk?
We've got a really interesting situation brewing, which is that humanity's use of space has advanced much more quickly than humanity's regulation of the use of space. So people still work according to the Space Act of 1967, when there were just a few countries occasionally launching things. You've now got SpaceX launching 8,000 Starlink satellites and doing these tests of these wonderful big rockets that will send people to the moon and beyond. But they don't really have to answer to anybody. What happened back on January 17th was the latest test of their Starship mission. Now, this led to some delays of Qantas flights, believe it or not, across the Indian Ocean, because this thing, had it worked, the upper stage was meant to splash down in the Indian Ocean. You can't fly there when there's a rocket about to re-enter, so Qantas were having delays. And there's a lot of questions about how much accountability should there be? Should there be a case where companies like SpaceX have to file a flight plan? If you're a terrestrial person and you're flying a plane, you log a plan so that everybody knows what you're doing and when you're doing it. But you don't have any rules like that just yet for spaceflight and for missions like SpaceX launching big rockets.
Yes, and in the case that you've just mentioned, Qantas having to delay its flights between Sydney and Johannesburg, are there legitimate fears for air travelers and airlines?
It's a relatively low risk, but it's not a zero risk. So anytime you've got things coming in back through the atmosphere breaking up, you don't really want aircraft to be in the same airspace. So over the Turks and Caicos Islands, when this thing detonated and fell down early, planes had to avoid that area for about 30 minutes. You had some planes actually getting relatively low on fuel avoiding it and getting prioritized landings when they got home as a result. Because it's better safe than sorry. You know, the atmosphere is huge. The area these things are coming in are vast. So the odds of one hitting an aircraft are minimal, but minimal isn't the same as zero. So you've got to be careful.
Okay, Professor Jonti Horner, really appreciate your fascinating insights. Thank you so much.
An absolute pleasure. Thank you for having me.